different denominators. So if the denominators do not match, we need to find the least common multiple, or our least common denominator. And so how we do this is we're going to multiply the denominators by missing factors. And then we will multiply the numerators by the same factors. So we have the same value of the fraction. And then we will, and if we don't know the least common denominator, you can always multiply the two numbers together. So let's go ahead and look at example 1. Example 1. In a parallel circuit, there are 4 different resistors, which are 3 ohms, 4 ohms, 4 ohms, and 5 ohms. The first step of finding the total resistance of the circuit is to do the following addition. And so we have R1 representing the 3 ohms, R2 representing 4 ohms, R3 is 4, and then R4 is the 5 ohms. So let's go ahead and rewrite this. So we have 1 over 3 plus 1/4 plus 1/4 plus 1/5. And so what we need to do is find the common denominator before we can add. Until we have that, we can't add these. Our least common denominator is a larger number just because of our unique numbers here of 3, 4, and 5. And so what we can do then is that we can rewrite these. So we have 1/3 plus 1 over 4, which can be broken down into 2 times 2. So then it's all in its prime factorization because 3 and 5 are already prime numbers. So what we can do is that we can multiply each of these numbers to see if we get our least common denominator. So what we would do then is off to the side to find the least common denominator. We can multiply 2 times 2 times 3 times 5. So 2 times 2 is 4 times 3 is 12 times 5 is 60. So that would be our least common denominator. So we need to get a common denominator on all these numbers to be 60. And so how we do that is we're going to multiply each term by its missing factors. So let's go ahead and do that. So we have 1/3. So we already have the 3. So the ones that we're missing is these 2 and this 5. So we would multiply the top and the bottom. 2 times 2 times 5, and then also on the bottom. This way, the bottom number now becomes equal to 60. And then we're going to add 1, 2 times 2. So all we're doing is missing from the 4, which is the 2 times 2, is we're missing these two factors. So we multiply the top and the bottom by 3 times 5, which is also 15. Then we do the same for the next one. And then finally we have plus 1/5. And so what we're missing from the 1/5 is the first 3 numbers. So we would multiply by 2 times 2 times 3, and then 2 times 2 times 3 on the bottom. So now let's go ahead and multiply this all out. So on the bottom, we will always get 60, because that's what we were solving for. Now we have 2 times 2 times 5. So 2 times 2 is 4, times 5 is 20. Then we have plus 3 times 5 is 15 over 60, and the same again. And then plus 1 times 2 times 2 times 3, which is 12 over 60. Now we have found our common denominator, and so now we can add. So in our final step, we were going to add all these numbers together. So let's go ahead and just do it on the right-hand side. So we have 20 plus 15 plus 15 plus 12. So 5 plus 5 is 10, plus 2 is 12. Carry the 1. 1 plus 2 is 3, 4, 5, and 6. So we have 62. So this is equal to, on the top we have 62, and we keep our common denominator of 60. Then we need to reduce because this is not its reduced form. So we can divide by 2 on both as they're both even. And so then we get 31 over 30. And this would be our reduced solution. So let's go look at another example. Now we have, in another parallel circuit, there are 3 different resistors. So just go ahead and ignore that one right there, which is 3 ohms, 2 ohms, and 6 ohms. The first step of finding the total resistance of the circuit is to do the following addition. So let's go ahead and rewrite this. So we have 1 over 3 plus 1 over 2 plus 1 over 6. So like we've done before, let's find our prime factorizations. So we have 1 over 3 plus 1 over 2 plus, and then 6 can just become 2 times 3. So our least common denominator is then, for all the unique factors, is 2 times 3. So that's equal to 6. So this is a little bit easier on this problem. So now we can then multiply any denominator by the missing factor, and we'll also multiply the top. So now we have 1/3. So here we have 1/3. It's missing the 2 to equal, because then 3 times 2 is 6. So we just multiply the top and the bottom by 2. Then we have plus 1/2. We're going to multiply the top and the bottom by this 3 because we're missing it. And then we're going to leave actually the last term by itself because it's already 6. So we don't need to multiply the denominator or the numerator by this number to get to 6 for the denominator. So now we can then multiply this all out. So we have 2 times 1 is just 2, which is over 6, plus 1 times 3 is 3 over 6, plus 1 over 6. So here we have our final thing that we can do, which is add. So 2 plus 3, which is 5, plus 1, which is 6. So we get 6 over 6 as we keep the same common denominator, and that can be reduced to just equal 1. And that would be our solution to our problem. So let's go ahead and look at another example. So we're going to solve for the following. In this one now we have a subtraction and we have an addition in the same problem. So we have 2/4 minus 5 over 12 plus 2/3. So let's go ahead and write the prime factorization for all these numbers. So we have 2, and then 4 becomes 2 times 2 minus 5 over 12. So 5 over 12 can become 2 times 2 times 3 plus 2/3, and that's a prime number. So our least common denominator will then be, we're going to take all the unique factors. So we have 2 2's, and then we have 1 3. So we don't need to multiply by 2 3's because this is just 1 3 in this term, and this is just 1 3 in that term. So now we then go back to our problem, and we would multiply the denominators and the numerators by the missing factors that we're missing here for our least common denominator. So for the first one, we're going to multiply it by 3 because we're missing this 3. And so when we multiply also by this, we got 2 times 2, which is 4, times 3, which is 12. So our least common denominator is 12. So that's what we're trying to get to for each of these numbers, to then have a common denominator of 12. So to get from 4 to 12, we multiply it by 3, That's what we just did. Now we have, this is already 5 over 12. So we're just going to leave as is. And then now we have the 2/3. Now from 3 to go to 12, we need to multiply it by 4, which is why we're going to multiply it by the 2 times 2, or which is also 4. So now let's go ahead and multiply this all out. So the first top, we're going to multiply it by 2 times 3. So we get 6 over 12. Next, we're going to multiply by 5 over minus 5 over 12, because that's what we already have. So we'll leave as is. Next, we have 2 times 2 times 2 for the top. So we get that's equal to 8, which is over 12. So let's go ahead and now solve, as we have had our common denominator. So we have 6 minus 5, which is equal to 1/12. Then we're going to go plus 8 over 12 to do our final thing. And that is equal to 9/12. But this is not its reduced form, as we can divide the top and the bottom by 3 to get us to 3 over 4. And this would be our final solution to this problem.